let's look at quality quant questions for week 10. This we will be doing TSD part 1. There will be more TSD parts coming in because it is a very difficult topic that gets tested in CAT in multiple ways. In this week, we'll be doing simple things, no circular motion, no escalators, upstream, downstream movement. This is simply based on standard TSD setups. Let's get through them one after the other. Okay, let's start. Boy walks home from his school. Boy walks from his home to school at 5 kmph, reaches the school 4 minutes early. If he walks from his home to school at 4 kmph, he reaches the school 2 minutes late. Find the time in minutes taken by him to go to school if he walks at 6 kmph. Now, this is the question part. Usually in TSD questions, your work has to be identify that parameter out of speed, time, and distance, which is identical in both the cases. In the first instance, there is a certain distance that he travels at speed of 5 km/h and it takes him a certain time. In the second instance, he travels the same distance at a speed of 4 km/h and it takes him a certain time. Given that distance is identical in both these cases, what we can equate is speed into time. So let's say the usual time that it takes him to travel to school is t. So in the first instance, he travels at a speed of 5. The time it takes him is t minus 4. And in the second instance, he travels at a speed of 4. The time that it takes him is t plus 2 because he is late. The first instance, it is t minus 4. The second instance, it is t plus 2. If you have framed equations or expressions like this is where the trap of units also comes into play. Look at what we have done erroneously. The speed was given in km/h, but the time was given in minutes. You cannot have km/h and minutes interacting with each other. And therefore, ideally what we should be doing is either understand that the time that we are talking of is in minutes, and then perhaps something of this nature can be done, or write this down, the time 4 minutes early, write it down at 4 by 60 and 2 by 60. One of those two understandings have to be clear in your head for you to be able to solve this correctly. I will solve it in both ways. Let's say if it was t minutes, the time it takes for him to reach school is in t minutes, then this is perfectly all right, because then units on both the sides are identical. If I equate this, I get 5 by 4 is equal to t plus 2 by t minus 4. The difference between the numerator and the denominator is 6, the right hand side, and the difference in ratio terms is 1, which means it is 24. T minus 4 is 24 and t plus 2 is 30. Should mean t should be the normal time it takes him to get to school is 28 minutes. Normal time it takes him to get to school is 28 minutes. We can solve it this way. We can also solve it in a simple equation manner, which will get us to the same working. Let's say I open it up, I get 5t minus 20 is equal to 4t is 8, or t is equal to 28. It takes him 28 minutes to get to school usually. Remember, this t minutes was usual time. Okay, in such a case, see how much distance is he actually traveling? He's traveling at the speed of 5 kmph for 28 minus 4 for 24 minutes, which is 2 by 5 of an hour. 2 by 5 of an hour. While figuring out t, we could do it in minutes, but now when I'm calculating distance, because 5 is in km/h, the time taken should also be in hour, which gets us to the distance is 2 kilometers. The distance is 2 kilometers. Now, if the distance is 2 kilometers and he's traveling it at the rate of 6, the time taken will be equal to 2 by 6 or 1 by 3 of an hour. But the question was find the time in minutes. So we don't stop it here. 1/3 of an hour is equal to 20 minutes, or the answer to this question will be 20. This is solving it when I took my initial variable t as minutes. If I took it in hours, then process remains the same. It is just that I'd have to t minus 4 by 60 is equal to 4 times of t plus 2 by 60. So we get 5t minus 20 by 60. I'm choosing not to. I'm choosing not to uh, cancel stuff out. Make it 1 by 15 and 1 by 30. Not really. Is equal to 4t plus 8 by 60, which gives us the time taken in hours is 28 by 60. The time taken in hours is 28 by 60 or 28 minutes. And then we do the same processing again. When we are moving at the rate of 5 km per hour, it takes us 24 minutes. Then what is the total distance? Then what is the total time taken? If we are traveling at the rate of 6, the subsequent solving will be the same. But then when you're framing this or you're framing this, be very, very careful. While you're taking a variable, the unit that you're using should be very, very clear in your head. What unit are you working? Okay, moving on. Next, a thief was running along to a median on a road at 6 kilometers per hour. So think of it this way, image-wise, what is happening? Sorry, don't need a circle, we need a line. Let's say this is the median on the road. Median on the road is a divider. Think of it as a divider. India, we use the term divider. A thief was running along a median on a road at 6 kmph. Let's say this is where the thief is. He's running at 6 kmph. He crossed a police jeep moving at 9 kmph in the opposite direction. So the jeep is here. Jeep is moving in the opposite direction at 9 kmph. Okay. The jeep had to continue for 10 more minutes before it could find a gap in the median and start chasing the thief. What they're saying is the jeep will go forward for 10 minutes, then make a U-turn and start chasing the thief. It will go forward for 10 minutes, then make a U-turn and start chasing the thief. So for 10 minutes, the thief is moving forward at the rate of 9. The thief is moving backward at the rate of 6, or they are getting separated at the rate of 15. So at the point when jeep is here, point when jeep makes a U-turn, point when jeep makes a U-turn, by then 10 minutes or 10 by 60 of an hour, for which the jeep and the thief are moving in opposite directions. So their relative speed in that instance will be 15. So they would have been separated by 2.5 kilometers. They would have been separated by 2.5 kilometers. And this is at the instance when the jeep has made a U-turn and then it starts chasing the thief. Okay. Find the total time taken by the jeep to catch the thief from the time that it crossed it. From this instant, when the jeep has made a U-turn, see the thief is running forward at the rate of 6. The jeep is still chasing him at 9 kmph, and the gap between them is 2.5 kilometers. Understand, diagrammatically, this is not precisely the case, because I think some people will have a challenge to this. I will make it. In the time that jeep has gone forward, the thief would have also gone forward some distance. Thief would have managed to reach here. Thief would have managed to reach here. So currently, what is the state? Currently, we don't have this reference of jeep. We don't need it. Perhaps we do need it because that will be important. When the jeep has made the U-turn, the thief would have moved some distance forward. When the jeep has made the U-turn, the thief would have made some distance forward. So I will name those things. This is the thief at the start. This is the thief after 10 minutes. This is the jeep at the start. This is the jeep after 10 minutes. Now, in what time will jeep catch up to the thief? The gap between is 2.5 kilometers. The gap between them is 2.5 kilometers. That is how separated they'll be. And the jeep is moving at the rate of 9 kmph. And the thief is moving at the rate of 6 kmph. Because they are moving in the same direction, the relative speed will be 3. So the time for jeep to catch up to thief from this moment in time is going to be 2.5 divided by 3, which is equal to 5 by 6 of an hour, or in minutes, it will be 15 minutes. Now the final question is, find the total time taken by the jeep to catch the thief from the time that it crossed him. It will take 50 minutes for the jeep to catch up to the thief after making the U-turn, and there will be initial 10 minutes of going forward. So total time taken by the jeep to catch the thief from the time that it crossed him, the answer will be 60. The initial 10 minutes spent here and the additional 50 minutes spent after this. Okay. Next question then. An artillery gun is fired twice at an interval of 24 seconds. A motorist moving towards the gun heard the sounds of the gunfire at an interval of 22 seconds. If the speed of sound is 330 meter per second, what is the speed of the car? Again, this is a fairly simple question if you know the setup. If you don't know the setup, see what is happening. The gun is being shot from the same location. So, shot one, and the time the motorist hears it, he is at some gap. He is at some gap. This is where motorist one. By the time the second shot is fired, the motorist would have come some distance closer. The motorist is moving towards the gun. He's moving towards the gun. In this time, whatever time was taken, let's say K, this time the motorist heard it 2 seconds earlier. 2 seconds earlier. Understand the time that you took from the sound of the gun being released to motorist hearing is not 24 seconds. It is just that he heard 2 seconds, he heard it 2 seconds earlier. What is happening is, from here to here, this event to this event, 24 seconds have passed. From the shooting of the first gun to the shooting of the second gun, 24 seconds have passed. But the motorist is hearing it as if only 22 seconds have passed between the two guns. Why is he hearing only two? Why is he hearing the second sound after 22 seconds? Because he has gotten closer. He has gotten closer to the source of the sound. If he had not gotten closer, imagine if he had not gotten closer, what would be the gap? What would be the gap between the two sounds of guns fired for him? It would have been 24 seconds only. If he had continued to remain stationary, if the motorist had continued to remain stationary, he would have heard the two guns being fired at a gap of 24 only. The fact that he has moved closer reduces the gap between two sounds to 22 seconds. What has exactly happened? In these 22 seconds, the motorist has covered some distance. And look at this special distance. This is where the game is. The motorist has covered this distance in 22 seconds. Motorist has covered this distance in 22 seconds. Let's call this distance D. For distance D, the motorist takes 22 seconds. But if he had continued to remain at his original position, the motorist had continued to remain at his original position, he would have heard the sound after 24 seconds, which means sound 2. Sound would have covered this distance in 2 seconds. The sound would have traveled this far in 2 seconds, while the motorist has taken 22 seconds to cover this distance. For the same distance, the time taken by the motorist and the sound is in the ratio 11:1. Therefore, the ratio of speeds, this is the ratio of times. So ratio of speeds will be inverse of this. It will be 1:11. speed of motorist and speed of the sound is going to be 1:11. And we are told speed of sound is 330 meter per second. If 11 corresponds to 330 meter per second, speed of the motorist will be 30 meter per second. 11 units is 330, so 1 unit is 30. And the answer to the question will be simply 30. It's a very, very basic setup. Ideally, everyone should know it, but I've gone into great detail with the expectation. If you don't know it, then how do you think? Okay. Okay. Question. P and Q are 2 points 10 kilometers apart. Anand started from P towards Q at the same time. Ashok started from Q towards P. They crossed each other after 1 hour. Okay. So the line there is P and Q. They are separated by 10 kilometers. The entire distance is 10 kilometers. Anand moved this way and Ashok to this. They crossed each other after 1 hour. Let's say they met at some point in between N. This is where they meet. And they crossed each other after 1 hour. When they're moving towards each other, they would meet when they have covered this entire distance of 10 kilometers. So let's say the speed of Anand is X and speed of Ashok is Y. X plus Y, the speeds into the time of 1, they have covered a distance of 10. But the sum of their individual speeds is 10. Sum of their individual speeds is 10. After that, Anand reduced his speed by 2 kilometers. And Ashok increased his speed by 2 kilometers. Anand now is moving at the rate of X minus 2. Ashok now is moving at the rate of Y minus 2. Sorry, Y plus 2. He has increased his speed by 2. They reach their destination simultaneously. Find Anand's initial speed. Find X is the question. Now see if they're reaching the destination simultaneously. The distance of PM, Anand has traveled that. Let's say PM, he has traveled that at the rate of X, and MQ, he has traveled that at the rate of X minus 2. Correspondingly, Ashok has traveled the distance of MQ at the rate of Y and traveled PM at the rate of Y plus 2. And the time taken in both these cases is identical. Time taken in both these cases is identical. Now, what this should tell you is, wonderfully, just observation of this equation. Observation of this equation should be that X minus 2 is equal to Y, or X is equal to Y plus 2. Only then would this equation balance out. X minus 2 is equal to Y, or X is equal to Y plus 2. If you're able to arrive at these conclusions, then going back to this original space, X plus X minus 2 is equal to 10, or 2x is equal to 12, or x is equal to 6. If you can make that observation. Otherwise, what we can do is, we can also solve it algebraically. See what has happened. In 1 hour, Anand had traveled PM distance. What is PM distance? It is distance of x. And in 1 hour, Ashok had traveled MQ distance. What is this distance? Y distance. So x traveled at the rate of y plus 2 is equal to y traveled at the rate of x minus 2. You can potentially solve it this way also. This will give us x square minus 2x is equal to y square plus 2y, or this is x square and y square I take over to the one side, and 2x and 2y I take over to the other side. x square minus y square equal to 2x plus 2y, or x minus y into x plus y is equal to 2 times of x plus y. So x plus y gets cancelled. This gives us x minus y is equal to 2. Then you can go back to the original equation. So x minus y is equal to 2, x is equal to y plus 2. Then you can replace it here, get to your individual value. Given that we wanted Anand's initial speed, answer to the question will of course be 6. Okay. Next question. A train approaches tunnel AB. Inside the tunnel is a cat located at a point that is 3 by 8 of the distance AB measured from entrance A. So I'm saying, let's say this is the start of tunnel A, B, this is the end, and if this entire distance is 8k, if this entire distance is 8k, the cat is at the 3k spot. The train that is approaching is somewhere here. This is where the train is going. The train is moving this way. This is where we have our cat. This is where we have our cat. Now, when the train whistles, the cat runs. The cat moves to the entrance A of the tunnel. The train catches the cat exactly at the entrance. If the cat moves to exit B, the train catches the cat at exactly the exit. What is the ratio of speed of the train to that of the cat? Let the speed of the train be T itself. When they are meeting at point A, cat is traveling this way, the train is traveling this way. Let's say this distance here is k or n kilometers. So n traveled at the rate of t is equal to 3k, where the speed of cat is c kilometers per hour. Cat move at c. The time that the train travels n kilometers, the cat travels 3 kilometers. This is fine. This is one expression that we have. This is when they meet at exit A, the opposite end of the spectrum, if they are moving towards exit B. In this instance, the train will travel n plus 8k at the speed of t. The cat will travel 5k at the speed of c. Now, I can break down this right-hand side expression. N by t is 3k by c. You can put that down here, which tells me 10 by t is 3k by c. So we can put it plus 3k by c plus 8k by t, 8k by t is equal to 5k by c. The wonderful thing is I can quickly get rid of all the k's. This k and this k and this k is gone. This 3 by c comes over to the right hand side. I have 8 by t equal to 2 by c, where t and c are speeds of train and the cat. T by c is going to be 4 by 1, or the answer to the question is option 1. Now, logically, see what is happening. When they are moving towards each other, the time that it takes, when they are moving towards each other, the speed with which they move is speed of the train plus speed of the cat. Speed of the train and speed of the cat, when they're moving towards each other at exit A, they're moving towards each other. The time that it takes is, the speed with which they move is t plus c. When it is moving away towards exit B, it is moving towards exit B. The speed with which the train catches up with the cat is t minus c. Now about time. Can you see? Just look at cat. The time that it will take to travel 3 units of distance versus the time that it will take to travel 5 units of distance will be in the ratio 3:5. The time that the cat will take to travel 3 units of distance and travel 5 units of distance will be in the ratio 3:5. If the ratio of speeds is t plus c by t minus c and the ratio of times is 3/5, can I say the ratio of speed has to be the inverse ratio of time? Or t plus c by t minus c should be 5/3. This leads us to beautiful solving of 3t plus 3c is equal to 5t minus 5c, or 2t is equal to 8c, or t by c is equal to 4/1. This way we wouldn't have to introduce many more variables, just this much working. The ratio of times taken in both these instances is 3:5. So the ratio of speeds should be inverse of that. That gets us to our solution fairly quicker. But even if you do it the other way, it is perfectly all right. But next question. After traveling for 30 minutes, a train met with an accident and was stopped there for 45 minutes. Due to the accident, its speed reduced to 2/3 of its initial speed, and the train reached its destination 90 minutes late. Had the accident occurred 60 kilometers after the point it occurred earlier, the train would have reached 30 minutes earlier than it was reaching after the previous accident. Find the length of the journey. What is critical for us to understand here is what exactly is the storyline. Let's say after traveling for 30 minutes, this is where the accident happened. This journey was covered in 30 minutes. Accident happened. And now, if the speed here, time is 30 minutes, speed is, let's say, 3x. Now, because of accident, 45 minutes was wasted here. Stopped there for 45 minutes. Now, train moved forward with a speed of 2x. Train moved forward with a new speed of 2x, and the time that it took it, see, if it had been moving with the normal speed of 3x, it was planning to travel this distance at the speed of 3x. So the ratio of times taken in these two instances, the new time taken and the old time taken, the ratio would have been 3:2. But how much was the train late by? Train is late by 90 minutes. Of these 90 minutes, 45 minutes was due to the accident, and then additional 45 minutes on account of the time traveled here. So the new time taken would be, will be in the ratio 3k and 2k, and the gap between these two is given to us as 45 minutes according to the question. So the time taken here was 135 minutes, and originally the distance was supposed to be traveled in 90 minutes. That is why we get 60 minutes late. 45 minutes extra due to the speed reducing, and 45 minutes due to the accident. 90 minutes later, not 60 minutes late, 90 minutes late. 45 minutes extra due to reduction in speed, and 45 minutes due to the accident. This is what is happening in the original story. Now, in the subsequent storyline, what are they telling us? Say, same route, same everything is happening. Had the accident occurred 60 kilometers after the point it occurred earlier. So the accident is not happening here. The accident is happening somewhere here. This is where the accident is happening. And the gap between these two phases is 60 kilometers. Gap between these two phases is 60 kilometers. Okay. So, had the accident occurred 60 kilometers after the point it occurred earlier, the train would have reached 30 minutes earlier than it was reaching after the previous accident. See, the accident will still use up 45 minutes. We are being only 60 minutes late now. In the second phase, the train had planned to move at a speed of 3x, but it actually moved at 2x, two-thirds the speed. So the ratio of time will be 3:2. Ratio of time will be 3:2, and that differs by 15 minutes, which means that now the time taken for this journey, the planned time would be 2 units. The extra time would be 15 minutes, 3 units or 15 minutes extra. So 45 minutes and much 30 minutes. Which is to say, understand this wonderful idea. You can look at it in two ways. First, for this portion after the accident, the time was 135 minutes, but now the time has become one third of that. Which means we are now traveling one third the distance. We are traveling one third the distance. Two-thirds the distance is already accounted for here. If two-thirds the distance is accounted for here and it is 60 kilometers, one-third the distance will be 30 kilometers. This time the accident is happening 30 kilometers prior to the destination. Previously, the accident was happening 90 kilometers prior to the destination. Now, in normal 30 minutes of time, the train travels 30 kilometers. So even in the initial phase, the train would have traveled 30 kilometers only. See, in this range, the train would have traveled 30 kilometers only. Therefore, the length of the entire journey will be 30 plus 60 plus 30 or 120. But we were arriving at this conclusion on account of 135 and 45 being good numbers. The other way to look at it is look at the diagram above and the diagram below. Can you see for this phase, the gap in time taken, saving of 30 minutes is happening because in the earlier case, we covered this distance at 2x speed, and in this case, we are covering this distance of 60 kilometers at 3x speed. So speed here is 2x, speed here is 3x, which means the time taken should be in the ratio 3:2. And if the time taken is 3:2, we know 30 minutes was being saved. So time here for this distance will be 90 minutes, and time here for this distance will be 60 minutes. So that the gap between them is 30 minutes. The 30-minute delay is happening, which now translates to, see, for 60 kilometers, time is 60 minutes. For 60 kilometers, time is 60 minutes when traveling at the speed of 3x. When traveling at the speed of 3x, if the time is 30 minutes, this distance here should be 30 kilometers. Originally, with the speed of 3x, if time taken is 30 minutes, this distance here should be 30 kilometers. Again, the total length of the journey will continue to be 120 kilometers. Understand, TSD is such a beautiful idea, beautiful concept that you don't really solve a lot of equations here if you can make a story out of it. More often than not, the ability to make a story is the key differentiator between you being able to solve something and you getting stuck in something. Okay, next question now. The distance between A and B is 19 kilometers. Cyclist starts from A at a constant speed towards B. Car leaves from A 15 minutes later in the same direction. In 10 minutes, it catches up with the cyclist and continues towards B. First part, I'm going to take care of. See, this is A, this is B. The cyclist starts. Then the motorist starts. Car starts. By the time they meet, let's say this is their meeting point. Cyclist has traveled for how many minutes? 25 minutes. Because the car started 15 minutes later and 10 minutes later, it was caught up by the car. And the car has traveled 10 minutes. For the same distance, the ratio of time taken is 5:2, which is to say ratio of their speeds. Speed of the cyclist is 2x, the speed of the car is 5x. Speed of the cyclist is 2x and speed of the car is 5x. Basically, the ratio of speed of cycle and car is 2:5. Okay. 10 minutes, it catches up with the cyclist and continues towards B. After reaching B, it turns around, and in 50 minutes after leaving, the car encounters the cyclist the second time. Okay. Now see, journey-wise, what has happened? What has the car done? Car went forward, then started returning. What has the cyclist done? The cyclist has continued going forward. Let's say this is the point where they meet for the second time. For how long has the car ridden? The car has been driven for 50 minutes. So with a speed of 5x, the car has been ridden for 50 minutes or 5/6 of an hour. This is the distance traversed by the car. What is the distance traveled by the cyclist? The cyclist has traveled with a speed of 2x. The speed of 2x, it has been driven for 65 minutes or 13/12 of an hour. Can you see? Together, just look at these blue lines. Together, they have traveled 2 times the entire track length, or sum of their respective distance traveled should be equal to 38 kilometers, because the distance between A and B is 19 kilometers. This is what we are looking to solve. So this becomes 6, 25 plus 13 divided by 6. So I get 38 x by 6 is equal to 38, or x is equal to 6. If x is equal to 6, remember what do we need? We need the speed of the car. The speed of the car was 5x. The speed of the car will now be 30 km per hour. The speed of the cyclist will of course be 12 km per hour. But we were never looking for 12 km. We were never looking for speed of cyclist. We were looking only for speed of car. So it will be option A. Okay. Next. Ram, Sham and Hari went out for a 100-kilometer journey. Ram and Hari started the journey in Ram's car at the rate of 25 kilometers per hour, while Sham walked at the rate of 5 kilometers per hour. For some time, Hari got off and started working at the rate of 5 kilometers per hour, and Ram went back to pick up Sham. All three reached the destination simultaneously. The number of hours required for the trip was, again, diagrammatically, it is best understood. See, this is the entire 100-kilometer journey. This is the entire 100-kilometer journey. How is Ram traveling? No, Hari. How is Hari traveling? The two important people here are Hari and Sham. If you look at how they travel, Hari, first he is traversing for some distance at the rate of 25 kmph. Then he gets off here. Then he is traversing at the rate of 5 kmph. How about Sham? What is he doing? Sham is first traversing at the rate of 5 kmph. He's first walking, and then when Ram comes back to pick him up, in his scooter, he is traversing at the rate of 25 kmph. Can you see, if Hari and Sham are reaching the destination simultaneously, can I say the spot from where Sham was picked up, or the distance traveled by Sham while walking and the distance traveled by Hari while walking has to be identical? This is x. This has to be x. This is, if this range is x kilometers, this range has to be x kilometers. Look at Hari, he has traveled x kilometers at 5 kilometers per hour. and 100 minus x kilometers. 100 minus x kilometers at 25 km per hour. Similarly, Sham has traveled x kilometers at 5 km per hour and 100 minus x kilometer at 25 km per hour. So time for Hari and Sham is going to be x by 5 plus 100 minus x by 25. This is the time taken. Now, so far, we have only been looking at Hari and Sham. The interesting person to note here is Ram. Look at Ram's journey. First, he travels this far. Then he comes back here and picks up Sham. Then he goes to the end all over again. So, if we are to break this down, journey to different parts, he travels x. This portion here is 100 minus 2x, this distance. And this 100 minus 2x distance, Ram has covered 3 times. First time while going, second time while returning, and third time while going again. And then this is x, this is 100 minus 2x, and this is x. So the total distance traveled by Ram, is x plus 3 times of 100 minus 2x and the final x again. And he travels it at what speed? He travels this entire distance at the speed of 25. Time for Hari and Sham. This is time for Ram. And we are told all 3 of them reach the destination simultaneously, which is another way of saying these 2 expressions have to be equal. So let's work our magic. First thing I can make is this. I will turn this to 5x by 25. So 5x plus 100 minus x. That is 4x plus 100 is equal to 2x minus x. So minus 4x plus 300 or 8x is equal to 200 or x is equal to 25. If x is indeed 25, see this portion here is 25 kilometers. This portion here will be 50 kilometers. This portion here will be 25 kilometers. Now the total time taken, 25 by 5 plus 75 by 25, which should be equal to 5 hours plus 3 hours for a total of 8 hours should be the answer. You can also look at Ram's version. Ram's version would be, he's traveled how much distance? X plus x. So 21 hour first or 75 distance at the rate of 25. So 3 hours. Then 50 distance at the rate of 25. So 2 hours. Then 75 distance at the rate of 25. So 3 hours. He will also take 8 hours. The answer to the question will be 8. Okay. 8th question, answer is 8. Absolutely wonderful. Next question. On a 20-kilometer tunnel connecting 2 cities A and B, there are 3 gutters, 1, 2, and 3. The distance between gutters 1 and 2 is half the distance between gutters 2 and 3. The distance from city A to its nearest gutter, gutter 1, is equal to the distance of city B from gutter 3. Okay. So storyline wise, what do we have? Everything that we have, we will write. We have A, we have gutter 1, we have B, roughly same distance, gutter 3, and we know distance between gutter 1 and 2 is half the distance between gutter 2 and 3. So 2. So if this distance is x kilometers, this distance is 2x kilometers. If this distance is y kilometers, the distance from city A to the nearest gutter, gutter 1, is equal to the distance of city B from gutter 3. This is y kilometers. Distance wise, this is the image that has been created. On a particular day, the hospital in city A receives information that an accident has happened at gutter 3. There is an accident. Okay. A victim can be saved only if an operation is started within 40 minutes. Only if an operation is started within 40 minutes. Okay. An ambulance started from city A at 30 kilometers per hour and crossed gutter 1 after 5 minutes. At 30 kilometers per hour, if you have crossed gutter 1 after 5 minutes, it means 30 into 1 by 12. This distance here is actually 2.5 kilometers. 30 into 1 by 12. 5 minutes is 1 by 12 of an hour. It is 2.5 kilometers. Okay. This is done. If the driver had doubled the speed after that, what is the maximum amount of time? What is the maximum amount of time would the doctor get to attend the patient at the hospital? Assume 1 minute is elapsed for taking the patient into and out of the ambulance. Okay. Okay. Now I also know one interesting thing. This is a 20-kilometer tunnel. I had completely missed this data point, and therefore I was worried. If this is 2.5, this distance is also 2.5 kilometers, which means this distance 3x is 15 kilometers. So this is 5 kilometers. This is 10 kilometers. Now see, journey wise, what has the ambulance undergone? It traveled this 2.5 kilometers in 5 minutes. But beyond this, after crossing gutter 1, it has made the journey this way. Journey has been made this way. The speed here is equal to, the speed here is doubled. An ambulance started from city A at 30 kilometers per hour and crossed gutter 1 after 5 minutes. If the driver had doubled the speed after that. Now the speed has become 60. What is the distance that the driver is traveling? 5, 10, 10, 5, 30, 32.5. 32.5 kilometers it is traveling at the rate of 60 kmph. So the time it will take will be 32.5 minutes. So for this journey from gutter 1 to coming back to the hospital, the time that the ambulance will take is 32.5 minutes. But this is not all the time. It also took 5 minutes earlier to get to gutter 1. So the total time it has taken is 37.5 to get back to hospital. It has taken 37.5 minutes to get back to hospital. So what is the maximum amount of time would the doctor get to attend the patient at the hospital? Assume 1 minute is elapsed for taking the patient into and out of the hospital. Now see, you receive information about the accident. Within 40 minutes, you have to bring the patient to the hospital. 37.5 minutes is your traveling time. And 1 minute is also used up for getting the patient in and out of the ambulance. So how much time is available to the doctor? Time available to the doctor will be 40 minutes minus the travel time minus the time used up in getting the patient in and out of the ambulance, which is 40 minus 38.5. So the time available to the doctor will be 1.5 minutes only, or option C will be the right answer. Okay. Next question. X and Y are stationed at points A and B respectively. Every day, X and Y. Okay. First, let me draw points A and B. This is point A, this is point B, this is X, this is Y. Stationed at point A and B only. Every day, X and Y start simultaneously from A and B and reach B and A respectively. So A starts from here, I starts from here, and they reach whatever point they reach. Every day they cross each other at point R. Okay. They meet each other, let's say at point R. From the point R, the time taken by X to reach B and the time taken by Y to reach A is 36 seconds and 16 seconds respectively. Okay. Now this is sort of critical piece of information. This is one of the building blocks of TSD based questions. Say if this distance was D1, this distance was D2. The time taken by X to reach R, or speed, let's say speed of X was small x, speed of Y was small y. What we have been told is D1 by X is equal to D2 by Y. This is the time taken for them to meet at R. After that, we have also been told D2 by X is equal to D2 by X is equal to time taken by X to reach B is 36, and D1 by Y, this distance to be covered by Y is equal to 60. So from here I can get to D2 is equal to 36x, and from here we can get D1 is equal to 16y. We can go ahead and replace it here. We'll get 16y by x is equal to 36x by y, or 16y square equal to 36x square, or x by y will be equal to 2 by 3. X square by y square will be 4 by 9. So x by y will be 2 by 3. Now see, while I've done it in this more expanded form right now, the insight that you should be aware of, if they start at the same time, from the meeting point, the ratio of times taken to arrive at the origins of the other person is the inverse of squares of the ratio of their speeds. So if it took 36 seconds and 16 seconds, if they took 36 seconds and 16 seconds, simply square root of this is 6, square root of this is 4, or the ratio is 3:2. The ratio of speeds of x and y should be instantly known as 2:3. So the speed here is 2x, speed here is 3x. If the speed here is 2x, the speed here is 3x. Okay, this working should be known. Or the expectation is you would know this working because we have studied time, speed, distance. Okay. One particular day, Y started late, and during that time, X had covered 20 kilometers. Okay. So what has happened is X has already traveled 20 kilometers. Acha. Can I also say, because the ratio of the speeds is 2:3, this D1 and D2 are no longer different variables for me to consider. This is, let's say, 2n kilometers. This is 3n kilometers. 3n kilometers. One particular day, Y started late, and during that time, X had covered 20 kilometers. This day, what is happening is, X is already 20 kilometers ahead of it. X is already 20 kilometers ahead of it, and is moving forward at the rate of 2x. Y is moving forward at the rate of 3x kilometers. Now, find the distance in kilometer between the point R and the point where they meet on that day. This total distance was 5n. This total distance was 5n. So now this distance, which is left for them to cover today, will be 5n minus 20 kilometers, because X has already traveled 20. Now the point where they meet will again be distributed in the ratio 2:3, because they're traveling for equal amount of time. From the moment that Y started moving and the moment that X started moving, they will travel distances in the ratio 2:3. So this distance will be 2n minus 8. This distance will be 3n minus 12. Finally, what they've asked me is this gap here from, let's say R was the usual meeting point. This is the new meeting point. I'm calling it T, their new meeting point. On this day when Y was late, this was their new meeting point. What they finally asked me is find the distance in kilometer between R and the point where they met on that day. This entire distance was 3n earlier. but where they are meeting this day is 3n minus 12. So this gap here has to be 12, or this entire gap between R and T is 12 kilometers, or this entire gap A to R is 2n. It's a different color. A to T is 20 plus 2n minus 8. The total distance traveled is 2n plus 12. From A to T is 2n plus 12, but A to R was only 2n. So the gap here has to be 12 kilometers. Understand, this 12 kilometers was on account of difference of 3n and 3n minus 12. This is not the distance between, as in this 2n minus 8, encompasses this distance, this entire from X to the meeting point T. This 12 is a separate idea. Finally, the answer to the question, find the distance in kilometer between point R and the point where they met on that day. The answer is 12 kilometers, or 12. Okay. Next question. Again, outstandingly wonderful question. Singur, Nandigram, and Kolkata are 3 villages on a straight road, such that Singur is somewhere in between the other 2 villages. Let's draw. I have Singur, Nandigram, and Kolkata. And Singur is somewhere between. So Singur is here, Nandigram and Kolkata. Nandigram and Kolkata. Distance of Kolkata from Singur is 10. So this gap is 10 kilometers. And distance of Kolkata from Nandigram is 70. The full thing is 70, which means Nandi to Singur is 7 kilometers. Hopefully, we did not end up taking Singur to Nandigram is 17 kilometers. Kolkata to Nandigram is 17 kilometers. Buddha and Biman started running from Singur at 9 a.m. Okay. I have Buddha. I have Biman. They start running from Singur at 9 a.m. The problem is we don't know in which direction they're in opposite directions at 4 meters per second and 3 meters per second. Which tells us there could be 2 possibilities. Either Buddha could be going left, or Biman could be going left. We have to take care of both those possibilities. Science ki 2 setups ready. Buddha could be running this way. Biman could be running this way. Buddha could be running this way. Biman could be running this way. The speeds of these people, Buddha was running at the rate of 4 meters per second, and Biman was running at 3 meters per second. Buddha was running at 4 meters per second, and Biman was running at 3 meters per second. Mamta starts from Nandigram in a car, going at 36 kilometers per hour towards Kolkata. But she started 10 minutes later than Buddha and Biman. Now, another thing that has triggered in my head, distance is in kilometer per hour. Distance is in kilometer. Speed of Mamta is in kilometer per hour. So I should ideally convert this speed, because the 4 meters per second and 3 meters per second don't tend to blend very easily with kilometer per hour. Number in kilometer per hour is going to be fractional. What I will do is change her speed into meter per second. Meter per second, it will be 10 meters per second. 36 into 5 by 18, no? Says 10 meters per second. Mamta moving at 10 meters per second. Mamta moving at the rate of 10 meters per second. Okay. But she started 10 minutes later than Buddha and Biman. So 10 seconds later, in 10 seconds, how far would they, or in 10 seconds, 10 minutes, 10 minutes is 600 seconds. In 600 seconds, where would they be? They would be at someplace. I don't know if I need to find that out right now. 10 minutes later than Buddha and Biman. So 10 minutes later, 10 minutes, 4 meters per second. In 1 minute, he would travel 240. 240 into 10, he would travel 2400 meters, or 7 minus 24 is 4.6. He would be at the 4.6 kilometer mark. Well, this fellow, 3 into 60 is 180. 180 into 10 is 1.8 kilometers. So 1.8 further than 7, 1.8. You would be at the 8.8 kilometer mark. This is where Buddha is. I'm calling Buddha as X and I'm calling Biman as Y. X would be at 4.6 and Y would be at 8.8. In the other storyline, Biman would be 1.8 backwards, so he would be at 5.2. Y is Biman, X is Buddha. Here, he would be at 5.2. Y here would be at 2.4 again. So at 9.4, X would be at 9.4. Okay. If the interval between the time Mamta met Buddha and the time when Mamta met Biman is approximately 15 whole 10 by 21 minutes, then find the distance in kilometer between Buddha and Biman. Find the distance in kilometer between Buddha and Biman when Mamta meets Biman. Okay. First thing, we need to figure out which of these two cases is working, which of these two cases is valid. So, meeting of Mamta and Buddha, meeting of Mamta and Buddha. Buddha is moving at the rate of 4, Mamta is moving at the rate of 10. So, time taken will be 4600 divided by 14. This is the time taken between Mamta's meeting with Buddha and Mamta's meeting with Biman. Mamta's meeting with Biman. What will be the time taken? It will be 8.8 divided by 7. 8800 divided by 7. If the difference between these two is 15 whole 10 by 23, sorry, 15 whole 10 by 21, okay, I can live with it. First, let me find out the difference here. It will be 168, sorry, 176 minus 46, 176 minus 46. So 13,000 by 14 or 6,500. Oh, I could have done that. 6,500 by 7. Now this is in seconds. This is in seconds. If I want this time in minutes, I need to divide it by 60. 6,500 by 7 seconds will be the gap between them. If I want this time in minutes, I need to divide this by 60. So cancel, cancel. I get this as 3. This as 325. I get 325 divided by 21, which is indeed 15 whole 10 by 21 minutes. So the case you are working for is definitely the left-hand side case. The case you are working for is definitely the left-hand side case. We can go ahead and reject the right-hand side case also. Between the meeting of Mamta and Biman, how much time has passed? 5.2 or 5,200 divided by 13, because they're moving towards each other, or 400 seconds. And between the meeting of Mamta and Buddha, the distance that is to be covered is 9,400 at the rate of 6, which will be something points, let's say, divided by 3, 4,700. So you'll get something in 1,500 plus 15. Let me not be cavalier, let me be precise. 15, 20 will give me 6. Then I will get 15.66. Can you see the difference between these two is going to be 1166 2 by 3 seconds. 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 1100, or why am I even doing this? Why am I getting it into decimals? It is not nice. 4700 by 3 will be the time between Mamta and Buddha's meeting. From the time that Mamta starts to the time that she meets Buddha, 4700 by 3 seconds will have passed. The difference between these two is going to be, this will become 1200. 3500 by 3, 3500 by 3 seconds. In order to convert this to minutes, I need to divide this by 60. Cancel, cancel. This will become 3. This will become 175. The gap in this case is turning out to be 175 by 9 minutes, or 19 whole 4 by 9 minutes. But we were told the gap is only 15 whole 10 by 21 minutes. So then if we were having bad luck, this is the first case we would have worked with. We'll eliminate this. We've got in here 15 10 by 12. Now we know the case, we know lots of storylines. What is the question? Find the distance between Buddha and Biman when Mamta meets Biman. Okay. See how much time has elapsed. How much time has elapsed since they started running far away from each other. Because all I need to do is they are moving away from each other at the rate of 7 meters per second. For how much time are they running away from each other? First, they were running away from each other for 10 minutes. And then they are running away from each other the time that it takes Mamta to meet Biman. So 10 minutes is 600 seconds. 600 seconds. And 8800 by 7 is the time that Mamta takes to meet Biman. So the total time will be 600 plus 8800 by 7. This is the total time. And for how long, and the relative speed, because one is moving at the rate of 4, the other is moving at the rate of 3. Relative speed is 7. So you'll get to 4200 plus 8800, or it will be 13,000 meters. They would be separated by 13,000 meters. But the question was asking me to find the distance in kilometers. And therefore, the final answer here will be 30. Hopefully, you understand why all these cases and all these workings had to be done. Let us move on to the next one now. This is a more typical version of the question. Nikhil reaches school every day at 5 p.m. to pick up his children. On Saturday, the school got over at 4 p.m. and the children started walking home. Nikhil met them on their way and returned home 30 minutes early. How long did the children walk? Let's say this is the distance between home and school. Usually, Nikhil goes up to school and picks up the children and comes back. But this day, what happened? Because the school got over early, the children started walking for some duration. And on account of that, usually the journey for Nikhil was this. But on this particular day, his journey became this. Picked up the kids midway. He went back home. This is the usual journey. This is this day's journey. Now, on account of this, because of the reduction in time, can you see he came back home 30 minutes earlier? If he came back home 30 minutes earlier, how has he saved time? He saved time going to school and coming back from school to this point. If he saved 30 minutes, he saved 15 minutes while going towards school, and he saved 15 minutes while coming back from school. If he saved 15 minutes while going towards school, if he saved 15 minutes while going towards school, it means he usually picked up the kids at 5 p.m. from the school. He usually picked up the kids at 5 p.m. from school. If he saved 15 minutes while going towards the school, this particular day, he picked up the kids at 4:45 p.m. Nikhil picked up the kids at 4:45 p.m. Now look at the poor kids. The school got over at 4 p.m. And they're getting picked up at 4:45. So how long did the children walk? The children walked for a duration of 45 minutes in total. Okay. Again, this is one of the more common basic setups that are used in TST, and ideally everyone should be aware of it. Okay. Moving on. A and B start moving towards each other simultaneously on a straight line from cities P and Q respectively. After traveling some distance, B takes a 30-degree turn to his left with respect to his original direction. 2 hours after B turned, A takes a 90-degree turn to his right. A travels 60 kilometers after turning before meeting B. They meet 10 hours after starting their journey. A and B together travel 170 kilometers before turning and arrive at the meeting point simultaneously. How many hours after turning did A meet B? Yeah, diagrammatically see what is happening. A straight line path from cities P and Q. A is going this way. B is going this way. After some time, Q takes a 30-degree turn, starts going this way. And 2 hours after that, A takes a 90-degree turn, this way. So what has happened is they have not traveled this part. The journey for B has been this, and journey for A has been this and this. Now, for these different parts, this is 30 degree, this is 90 degree. So by extension, the sum of angles of a triangle, this will be 60 degree. Now, A travels 60 kilometers after turning before meeting B. Means this distance is 60 kilometers on a 30, 60, 90 triangle. The angle opposite 30 degrees is half the angle opposite 90 degrees. So B has traveled 120 kilometers after turning. A has traveled 60 kilometers after turning. B has traveled 120 kilometers after turning. Okay. You're also told A and B together travel 170 kilometers before turn. So let's say if A traveled, I am calling this point M, calling this point PM plus NB is 170. So this is X. This is 170 minus X. This distance is X. This distance is 170 minus X. Now, in 10 hours, B has traveled 170 minus X plus 120. Wherein B has traveled 290 minus X. And A has traveled 60 plus X. Okay. Okay. Now, what can I work with? What do I need finally? How many hours after turning did A meet B? Okay, wonderful thing. They meet 10 hours after starting their journey. Together, the distance traveled by them is 350. Together, combined distance traveled by the two of them is 350. So, if I take speed of A as small a, so speed, I take speed of B as small b, can I say A plus B into 10 is equal to 350, or sum of their speeds is 35. Sum of their speeds is 35. Now, sum of the speed is 35. I can also go ahead and write this down. Before turning and after turning. Before turning, this is time, consideration of time. A has traveled for 10 hours. If after turning he has worked for he has moved for t hours. Before turning, he moved for 10 minus t hours. And B, after turning, he has worked for t plus 2 hours. He has moved for t plus 2 hours. And before turning, he has worked for 8 minus t hours. So, utilizing this, can I get to the distance traveled before turning? Both of them before turning, distance traveled is 170 in total. So 10 minus t into A plus t into B is equal to 170. 10 minus t into A plus t into B is equal to 170. Alternately, and when I do before turning, 10 minus t into A and 8 minus t to B, 8 minus t to B is equal to 170. One equation. The other equation is TA plus TB plus 2B is equal to 180. After turning, A has traveled 60 kilometers, B has traveled 120 kilometers. So TA plus TB plus 2B is equal to 180. I have these three equations available. I can turn this equation into 35T plus 2B is equal to 180. 35T plus 2B is equal to 180. Simply replaced A plus B with 35. Even this one, this equation, simplify. 10A minus, sorry, 10A plus 8B, 10A plus 8B minus TA minus TB. So minus 35T equal to 170. Can replace 35T as 180 minus 2B. So 10A plus 8B minus 180 minus 2B is equal to 170. No, but this is turning to 35 only. So this will not be minus 2B, it will be plus 2B. So this is not useful for us. I have this equation in A, B, something, something. So I can do this. 2A plus 8 times of A plus B minus 35T is equal to 170. 8 times of A plus B, 8 times of 35 is 70 to 280. So 2A plus 280 minus 35T equal to 170. 35T minus 2A equal to 110. Now I have this. Yeah. I think I'll have to go down this path. A is equal to 110 minus 35T by 2. B is equal to 180 minus 35T by 2. I'll have to put that in A plus B is equal to 35. 110 minus 35 plus 180 minus 35t by 2 is equal to 35. A plus B is equal to 55. Okay. And now I'm seeing I could have simplified this severely. Let's see what this leads us to. I get 70 here. 290. So this 110 appropriate. This is 170, this is 180. I have to work on this framing. Before turning, they have traveled 170 for the first time. Before turning, A traveled for 10 minus t, B traveled for 8 minus t. Divided. 10A plus 8B minus TA minus TB. So translates to minus 35t. Okay, perfectly all right. Now 8A plus 8B, replace it with 280. Perfectly all right. 280 minus 170 is 110. Perfectly all right. So 35t minus 2A is equal to 110. All right. So A is equal to A is not equal to this expression. A is equal to 35t minus 110 divided by 2, and B is equal to 180 minus 35t divided by 2, which will render our above expression useless. This will be equivalent to 35t minus 110 plus 180 minus 35t. So 35t, 35t gone. We are only left with constants, so this is not useful at all. This is not useful at all. Other thing you can look at. You can potentially look at this distance 60 divided by t. 60 divided by t plus b has started 120 divided by t plus 2. So 120 divided by t plus 2. This is the speed of A. This is the speed of B. This should be equal to 35. This is a much better framing. Get rid of this. Sorry, working. Yeah. And keep this down. A plus B is 35. This is now a beautiful equation in T. Solving it would be nice. First, let me get rid of 5s. This will turn 7. This will turn 24. This will 12. So 12t plus 24 plus 24t is equal to 7t square plus 14t. 7t square minus 26t. So we can say, no, not minus 26. It's 22t minus 22t minus 24 equal to 0. 7 into 24, if I break it down, 68, 168. So 28 into 6. 7t square plus 28t plus 6t minus 24 is equal to 0. 70 t minus 4 plus 6 t minus 4 equal to 0. So this gives us t is equal to 4 or minus 6 by 7. T is equal to 4 or minus 6 by 7. Given that t was time taken by A after turning, given that t was time taken by A after turning, it cannot of course be negative. So the answer here should be 4 hours. In how many hours after turning did A and B meet? After turning of A, 4 hours have elapsed. 4 hours have elapsed, and then A and B end up meeting. Okay, together they have traveled in 10 hours. They have traveled 350 kilometers, which gives us sum of the speeds is 35. And then bifurcated the portions of the journey as per time. Before turning, he has traveled for 10 minus t hours. After turning, he traveled for t hours. Because B traveled for turned 2 hours earlier. After turning, he has traveled for t plus 2 hours. And before turning, he has traveled for 8 minus t hours. Okay. This should enable us to get to after turning. A has traveled, the speed of A is 60 traveled in t hours. The speed of B is 120 traveled in t plus 2 hours. It should be equal to 35. Then it is a basic quadratic equation solving process. We get to 4. That should be the answer. Okay. Next is this is a two-parter. A spaceship A leaves Earth for Jupiter at noon on Monday, traveling at 30,000 km per hour. After 6 hours, another spaceship leaves another spaceship B leaves Jupiter for Earth, traveling at 50,000 km per hour. The distance between Jupiter and Earth is 9,80,000 kilometers. Assume spaceships move in straight lines and the planets are stationary with respect to each other. Okay. Should not be 15. Or should not be 15. Anyway. So A and B. Spaceship C leaves Earth 12 hours after A and meets A at the same time as B. What is the speed of C? What is important here is see that A, B, C they meet simultaneously. So if I find out the duration from the time that B leaves, where exactly do A and B meet? We are able to identify that. Then the distance that A has traveled so far, that has to be traveled by C in 12 less hours. Let's see. The distance was 980. No? This is why I like this. The total distance was 9,80,000. A started from here and B started from here. This way, B went this way, and C also started from here. So they started differently. By the time B started, A had traveled for 6 hours. It is traveling at 30,000 km per hour, so it could have traveled 1,80,000 already, which means the gap left between the two of them will only be 8 lakhs now. Now the ratio of speed of A and B is 3:5, 30,000 km per hour and 50,000 km per hour. So it is traveling 8 lakhs. Well, if they are cumulatively traveling 8 lakhs, 3 lakh more A would have traveled. They would have met at this point. 4,80,000 from A. From A it is 4,80,000, or from B it will be 5 lakh. So if a spaceship C leaves Earth, this is where A left. If C has to travel 4,80,000, C has to travel 4,80,000. In how much time also we have to figure out. 8 lakh traveled at the rate of 80,000, 10 hours extra was taken. A and B. From this point, from the time that B started, A and B take 10 hours to meet. So total time taken by A was 6 hours for this range, 10 hours for this range. So A has traveled for 16 hours so far. C leaves 12 hours after A meets. After 12 hours after A. So if A has traveled for 16 hours, C has to travel this duration in 4 hours. He has to travel this distance in 4 hours. In 4 hours, he has to travel 4,80,000. So the speed with which he has to travel has to be 1,20,000. Okay, 4,80,000 divided by 4. Next, the absolute difference between the time at which A reaches Jupiter and B reaches Earth. A reaches Jupiter and B reaches Earth is they meet here. They meet at this point. A has to travel 5 lakh more. 5 lakh distance at the rate of 30,000. So he will take 16 whole 2 by 3 hours or 16 hours 30 minutes. This is the time A will take after meeting here. What is the time that B will take? B has to travel 4,80,000 kilometers more at the rate of 50,000. So it will take 9.6 hours or 9 hours 36 minutes. This is not 16 hour 30 minutes, this is 16 hour 40 minutes. 2/3 of an hour is 40 minutes. 16 hour 40 minutes, 9 hour 36 minutes. So 4 minutes and 7 minutes. The difference in time is going to be 7 hour 4 minutes. And that is the entirety of question for both the subparts. Okay. Next. Consider a road with 2 cars at distance of 500 kilometers driving in opposite direction. The left side car drives at the speed of 40 km per hour and the right side car drives at a speed of 60 km per hour. A bird starts with the same location as the right side car and flies at a speed of 80 km per hour. When it reaches the left side car, it turns a direction. When it reaches the right side, it turns a direction again to the opposite and so on. What is the total distance in kilometer that the bird has covered until the moment the 2 cars reach each other? Okay, the wonderful thing here is this is a long way of asking a very simple question. In order to figure out distance, what are the 2 things we need? We need time and we need speed. What was the speed of the bird? Speed of the bird was given to us as 80 km per hour. For what duration are we considering? We're looking at 2 cars traveling at 40 and 60 towards each other. So the cars are traveling towards each other with a relative speed of 100. Relative speed of 100 kilometers per hour, and they have to cover 500 kilometers. The cars have to cover 500 kilometers. So the distance, this is for cars, this is for bird. The distance that the cars have to travel is 500 kilometers, relative speed is 100 kilometers per hour. Time taken will be 5 hours. Wonderful thing is, the duration that it takes for these 2 cars to meet is also the duration for which the bird flies. The bird flies for 5 hours. So how much distance has the bird traveled? 80 into 5, 400 kilometers. Here, the work will become difficult if you try to solve it piecemeal. What I mean by piecemeal is parts by parts. First, how much bird traveled this way, then how much bird traveled backwards, then how much bird traveled forwards, then how much bird traveled backwards. If you try to solve it that way, it will become insanely difficult. But then the question here is very, very simple. They've given us speed, they've given us an indicator for time, and they've asked us what is the total distance. All the calculation that is needed is present on the screen. Okay. Next, a car overtakes a bus traveling from Bangalore to Chennai at 6:30 a.m. The car reaches Chennai at 8 a.m. After stopping there for 1 hour, starts back towards Bangalore and meets the same bus at 9:30 a.m., which was moving towards Chennai at the time. If both the bus travel at uniform speeds on the route, what will be the time bus would reach Chennai? Okay. Please help. Let's say the spot where the car and bus meet. Car and bus. Instead of considering it as a point where the car is overtaking the bus, I'm saying car and bus are starting from here. They are here at 6:30. The car reaches Chennai at 8 a.m. This destination, Chennai, the car manages to reach here at 8 a.m. It means how long did the car take for the journey? Car from the point that they met, from the point where the overtaking happened to Chennai, the car has taken 1 hour 30 minutes. 1 hour 30 minutes. After stopping there for 1 hour, it starts back towards Bangalore and meets the same bus at 9:30 a.m. Let's say he meets the same bus here at 9:30 a.m. This journey from Chennai to the second meeting point, this has been only 30 minutes. From the first meeting point to Chennai, the journey was of 1 hour 30 minutes. From Chennai to the second meeting point, the journey has been only of 30 minutes. So can I say, if I take the entire distance, as 3x, this distance here has to be 1/3 of that x, because the time taken by car to cover the respective distances is 3:1. So distances will also be 3:1. Okay. So what has our bus done? Look at our bus. Our bus has covered 2x distance in 3 hours. Our bus from the meeting point to the second meeting point, from the first meeting point to the second meeting point, our bus has traveled 2x distance in 3 hours. So this x distance, it will travel in 1.5 hours. If it has traveled 2x distance in 3 hours, it will travel x distance in 1.5 hours. What will be the time when the bus would reach Chennai? From 9:30 a.m., 1.5 hours more, the bus will manage to reach Chennai by 11 a.m. That will be the answer. 9:30 a.m., 1.5 hours further. That is when the bus will manage to reach Chennai. Okay. Next question. A and B start simultaneously from P and reach R via Q along the same. Start from P, they reach R via Q. Let's say Q is in. A travels at 15 km/h from P to Q and 20 km/h from Q to R. B travels at 20 km/h from P to Q and at 15 km/h from Q to R. A reaches R 10 minutes before B reaches there. Okay. Let's say A, this range has a rate speed of 15. This range has a speed of 20. B in this range has a speed of 20. And in this range has a speed of 15. So time taken by A will be PQ. Let's say I'm calling this distance as x kilometers. This as y kilometers. X kilometers and y kilometers. Finally, I need x plus y. I also looked at the final distance between C and R. So I need x plus y. So x by 15 plus y by 20 is 10 minutes lower. 10 minutes lower. Remember, we are taking speeds in km/h, so time should also be taken in R. Plus 1 by 6 should be equal to x by 20 plus y by 15. This is what we are getting. Okay. So this is fine. Next, what do we have? If the time taken to cover PQ to the time taken to cover QR by B is in the ratio 1:2. Okay. So time taken to cover PQ is x by 20. Time taken to cover QR is y by 15. This is told to us as 1/2, which gives us a beautiful, we will know the ratio between x and y straight away. We will know the ratio between x and y straight away. Let's see. We'll get this will become 4, this will become 3. This gives us 3x by 4y equal to 1/2. So x by y is equal to 2/3. We know the ratio between x and y to be 2/3. So this equation that I have here, I will replace x with 2k and y with 3k. 3k by 15 plus 2k by 20 plus 1/6 is equal to replacing x with 2k, y with 3k. I have made the biggest cardinal sin. Written down numbers incorrectly. Should be 2k, should be 3k, plus 1/6 is equal to 2k by 20 and 3k by 15. Now 3k, 2k, we'll get k by 20 on the left minus, should I do minus? Let me do k by 20 plus 1/6 is equal to k by 15. 20, 15 and k. Get rid of this, so 60 is the best place. So this will be 3k plus 10 is equal to 4k, or k is equal to 10. If k is equal to 10, the distance x kilometer will be 20 kilometer, distance y kilometer will be 30 kilometer, and finally they've asked me the distance between P and R. That will be a total of 50 kilometers. Total distance will be 50 kilometers. Okay. Next question. Aisha started running from one end of a straight road at 5 hours, at 0500 hours. That is, she started running at 5 a.m. Bhumika, standing at the other end, started running towards Aisha at 0600 hours, which means 1 hour after Aisha started, Bhumika started running. Okay, and met Aisha at point P on the road. They continued running till they reached the opposite ends, turned back immediately, coincidentally met again at the same point P. If they met at point P for the first time at 700 hours, then what is the ratio of the speeds of Aisha and Bhumika? Okay, the diagrammatic work. See, let's say this is where Aisha started. This is the end from which Aisha starts. This is the end from which Bhumika starts. And this is the meeting point. So, if this is x kilometers, Aisha runs at her rate of A, Bhumika runs at her rate of B. This is y kilometers. Aisha has run x kilometers at the rate of A, x kilometers at the rate of A, and the time taken here should be y by B plus 1, because Aisha has run for 1 more hour. Aisha has run for 1 more hour. This we know. This is up until the first meeting. When we look at the second meeting, journey taken by Aisha is going to be like this. The journey taken by Bhumika is going to be this. Journey taken by Bhumika is going to be this. You can look at this journey in two ways, right from the beginning and from the meeting point, alone. When you look at it right from the beginning, Bhumika has traveled y plus x, 2x plus y by the Bhumika has traveled this much. This much up. This is the time taken by Bhumika. And this should be 1 hour lesser. This should be 1 hour lesser than the time taken by Aisha, which should be how much? X plus y plus y. So 2y plus x by a, 2y plus x by a. Now only from the meeting point. See, Aisha has taken, now the time is identical for both of them. 2y by a should be equal to 2x by b. 2y by a should be equal to 2x by b. You can operate with any of these understandings. Now, also understand, when I write this down, x by a, Aisha started at 5 and Bhumika started at 6 and they met for the first time at 7. So x traveled at the rate of a. I already know the time taken here. It was 2 hours. Aisha has traveled for 2 hours. Bhumika has traveled for 1 hour. So essentially what we also have is x by a is equal to y by b equal to 1. We already have these notations of numbers available in front of us. So let's work our magic. For the first one, we know something. For the second one, we know something. For the third one, we know something. This is right from the beginning, how much time is taken. This is from the meeting point, how much time is taken. I can say, what do I need finally? I simply need ratio of speeds too. So x is equal to 2a and y is equal to b. I know these two things. This expression would be most helpful. I put it here. 2y into b. If y is equal to b, I get 2b square is equal to a is equal, x is equal to 2a. So 2 into 2a, 4a equal to 4a square. And our life is insanely easy. A square by b square will be equal to half, or a by b. The ratio of speeds of Aisha and Bhumika is asked. So a by b will be equal to 1 by root 2. Or the answer will be option B. Next question now. Certain race is made up of 3 stretches, A, B, C, each 2 km long, to be covered by a certain mode of transport. The following table gives these modes of transport for the stretches and the minimum and maximum possible speeds in km per hour over these stretches. The speed over the particular stretch is assumed to be constant. So if you travel at a speed of 40, you will continue to travel at a speed of 40. You don't change it. Now, mentioning this particular speed or the fact that the speed remains constant over a particular stretch is actually a redundant piece of information, because in the TSD world, at least in the academic purposes or for question solving purposes in the CAT world, this assumption is already valid. Speed does not change over a particular stretch. Okay. The previous record for the race is 10 minutes. Mr. Tortoise completes the race at an average speed of 20 km per hour. Okay. See, if he completes the race at an average speed of 20 km per hour, he has each of the stretches were 6 kilometers. So 6 kilometers at the rate of 20 km per hour This is 3 by 10, or Mr. Tortoise has taken 18 minutes. Mr. Tortoise has taken 18 minutes. His average speed for the first two sections is 4 times that of the last stretch. Average speed for the first two stretches is 4 times of the last stretch. What is his? See, average speed is total distance by total time. Total distance by total time. So what is his? Is his average speed, average speed, average speed. His average speed for the first two stretches. First two stretches is 4 kilometers. His average speed there is 4 times that of the last one. So 4 by 4x. First stretch was traveled at the rate of 4x plus the last stretch of 2 kilometers was traveled at the rate of x. And this should give us the total time. This should give us the total time. Total time is given to us as 6 by 20 or 18 minutes. This is all that we have to solve. So in this goes, I get 1 by x, 2 by x. I get 3 by x is equal to 6 by 20, or x is equal to 10 kilometers per hour. This is also an example of a question in which a lot of information is given to you. But then when it comes to solving, not a lot needs to be done. Simply need to read the instruction and follow. Okay. Next. The triangular garden in Gopal Colony is to be enclosed inside 3 straight fences. Raju started running at a uniform speed on 3 sides of the proposed boundary of the garden. Discovered that he would take 48 minutes, 102 minutes, and 90 minutes to traverse the garden's 3 sides. This is, you should be able to identify these numbers have some meaning. These numbers have some meaning. Triangular garden. If you take 48 minutes, 102 minutes, and 90 minutes, the speed is identical. So the ratio of distances should be in the ratio of time. The ratio of time is 8:17:15. And this is a Pythagorean triplet. 8, 15, 17 is a Pythagorean triplet. So let this be the side that is 8k in length. Let this be the side that is 15k in length. Let this be the side that is 17k in length. This was traversed in 48 minutes. This was traversed in 90 minutes. And this was traversed in 102 minutes. These numbers are not just throwaway numbers. These are important numbers. This is where geometry and TSD have a confluence. Okay. To traverse the garden's 3 sides. However, in the latest colony meet, it was decided that the coverage area of the park would be reduced to accommodate a parking, since the fence on the shortest boundary was already constructed. Saying the fence on the shortest boundary is already constructed. The length of the boundary covered, since the fence on the shortest boundary was already constructed, the length of the boundary covered by Gopal in 90 minutes, this bottom length, was reduced by 60%. Previously, it was 15k. If it is reduced by 60%, it is reduced by 9k. So the new length, new mark where we are operating at, this length here will be 6k. This length here will be 6k. And the longest side of the garden was modified accordingly so that the park still remained in triangular shape. Now look at it. We have a right angle triangle with 8k, 6k, 3, 4. Of course, the third side has to be 10k. Of course, the third side has to be 10k. How much time in minutes will Raju take to run along the boundary of the garden thus far? Now see, previously it was 8 plus 15, 23, 23 plus 17. Previously he was running 40k. And what total time did it take him? 48 plus 102, 150. And 240 minutes it took him. Previously, he was running 40k distance. And it took him 240 minutes. Now in the new triangle, we've got 8 plus 6 plus 10. He's running 24k. 24 into 6. 24 into 6 is how much? 25 into 6 is what? So it will take him 144 minutes now. It will take 144 minutes for Gopal to run along the boundary of the garden pond. And that is the entirety of this sheet. Hopefully you learned something. There were questions, there were representation styles, there were ideas or standard formats that were new or worthwhile for you. As previously stated, this is part 1 of TSD. There will be more TSD specific videos coming up. Hopefully, you will watch them also and learn something else. That will be all. Thank you.